dynamic ARP inspection. Why do we require dynamic ARP inspection? Okay, so let's say, for example, consider a scenario. One switch will take two pieces. Okay, we will take two pieces. Now, while in the usual case, what will happen? These PCs will communicate, and initially they will not have the ARP cache and everything. They will perform the ARP resolution and they will get the ARP cache also. Okay, so understand it. This is the scenario. Let's consider the MAC address of this PC is M1. Okay, let me change the color. And the MAC address of this PC is M2. Okay, so these PCs, they will create the ARP cache. In the ARP cache, there will be entries. Let's say for PC1, the ARP cache will have the entry that IP address, let's say 10.0.0.2 is having the MAC address M2. Correct? And this PC will have the entry that the MAC address is M1. Correct? This is the ARP cache for PC1 and PC2. And let's say the IP addresses they have as 10.0.0.1, and this one is having what? 10.0.0. Okay. Now what, they will have the normal communication, that is no issue. But if a hacker connects to your network, let's say this guy is the hacker. Here's the hacker. He connects to your network. Now let's say his MAC address is M3. Okay. And his IP address is 10.0.0.3. Okay. Now what this hacker is going to do, he is going to generate ZR. Okay, before that, let me show you the switch cam table also. So switch will also generate the cam table. In the switch cam table, what will be the entries? That okay, on F0/1, I have the MAC address. What is the MAC address? MAC address. F0/2, what is the MAC address? M2. And when hacker will connect, so this will connect on, let's say F0/3, will have the MAC address M3. Okay. Now what will happen? This hacker will generate a ZR. Okay. Will generate a ZR here, this side. And in the ZR, this hacker is going to say, my IP address is 10.0.0.1 and my MAC address is M3. Now when this PC will receive the ZR, now you see ZRP is used for, first of all, checking IP address duplication. Second, announcing the IP to MAC mapping. So means basically it is announcing that, okay, my IP address is this, my MAC address is this. Now what your PC will do, it will say, okay, this guy is not here. Now this guy is available on M3. Similarly, your hacker will generate one more ZR. Okay, it will generate one more ZR this side. In this ZR, it is going to say what? I am 10.0.0.2. My MAC address is what? M3. And this is what your message is, ZR. And this is also ZR. Okay. Now what this guy will do? Okay, means your 10.0.0.2 this time not available on M2. It is available on M3. They will update their ARP cache. Okay. Now what will happen? when this PC1 will generate a packet for PC2. Okay, whenever let's say you want to send some data or something. So in that case, whenever your PC1 will generate a packet, what will be the packet? There will be source IP, destination IP, source MAC address, and destination MAC address. Source is 10.1, destination is 10.2. Source MAC is M1. What will be the destination MAC address? Looking in the ARP cache, M3. Packet will come to the switch. Switch will check. What is the destination MAC address? M3. For M3, on which port I will send? Check in the MAC address table. F0/3. Send it to the hacker. And then hacker will forward it to the correct. Now when M2 will reply, the PC2 will reply. The destination will be 10.1. Source will be 10.2. Source MAC will be M2. Destination MAC will be again, because it will check for 10.1 what is the MAC address in the ARP cache. M3. Forward it to the switch. Switch will check destination MAC address. M3. Forward it to port F0/3 from this side. Again, hacker will forward this side. So do you see what is happening here? Your entire data, entire traffic is passing through the. So hacker will be able to capture all your data. What all the usernames, passwords, and everything. Okay. So to avoid this kind of scenario, again, we will use which concept? Which concept? Dynamic ARP inspection. And the configuration of dynamic ARP inspection is similar. See, similar to your DHCP snooping only. How you will configure? IP ARP inspection. VLAN and then VLAN ID. Okay. Then interface, trusted interface name.
So maybe from the address. So even though like this machine is at 10.0.0.3, but if you need some third party tools, you can trigger like IM 10.0.0.1.
Exactly.
Something like that.
Correct. They can design custom packets. There are certain tools. This is the configuration. Do you see very similar to your DHCP snooping? Okay. So you'll just go and what all your trusted interfaces are there, you'll take in the range and you'll say these are the trusted interface. Now your dynamic ARP inspection will make use of a database. Okay. It will make use of a database. Dynamic ARP inspection. In short, DAI uses the DHCP snooping binding database to block unknown ARP requests, or the you can say unknown ARP or the ZARP messages. Okay, so what it will do in your DHCP snooping binding database, okay, there will be entries that which IP address has what MAC address. So if a new ARP is coming, it will check, see how it will happen. When we are using DHCP snooping here, so what will happen? Everything will come from the trusted interface. So let's say this PC is assigned with 10.0.0.1. Okay. So in the DHCP snooping binding database, there will be an entry that, okay, the 10.0.0.1 has been assigned to MAC address M1. 10.0.0.2 has been assigned to MAC address M2. Now, when a new PC M3 will come, so again an entry will be made, let's say 10.0.0.3 is having the MAC address M3. Now, when M3 will say, means interface F0/3, right? Through here, if a ARP will come and it will say I am 10.0.0.1 and my MAC address is M3, is it matching this database? No. Means something suspicious, drop it. So your ARP will not forward. If your ZR will not forward, what will happen? If these GR messages will not be forwarded, these ARP cache will not be modified, right? And if these ARP cache will not be modified, is the switch going to send the packets here? No. This is how you're going to avoid your, and this particular attack, it is also known as man in the middle attack.
So before reaching the PC, it will ask create a server. So this ARP is function. Before reaching to the end user's PC, it will ask for DHCP server database.
This DHCP snooping binding database, this is available in the switch. This is available in the switch. Only this database will have IP to MAC mapping in the switch. Okay. And with the help of this database, your switch will make the decision. Is it the correct or not? If it is not correct, just drop it. Clear? Okay.